University, Bangkok, Thailand. So first of all, I would like to thank the organizing committee, Kyushu Institute of Technology, Sakura Sai Exchange Program Inside, and also Thammasat University to give me a chance to present some of the research work on the topic of gold porphyrins and their derivative for applications. So first of all, I would like to present the basic information about the porphyrin first. The porphyrin is the macromolecule. The basic unit of porphyrin is composed of 4 modified pyro that's connected with the carbon-methane bridge. The porphyrin found in nature, we found in heme, chlorophyll, and vitamin B12. So in heme, iron will connected with the nitrogen in the center hole of the porphyrin by sharing electron between nitrogen donated electron to iron to form heme. In case of chlorophyll, magnesium will attach into the metal center, and also copper and also cobalt will attach to the center of the porphyrin to form the vitamin B12. To synthesize the long chain porphyrins, we have to prepare the aldehyde first. When we get the aldehyde, it will react with the pyro by using the propionic acid at 343 kelvins by refluxing. After we get the purify free bed porphyrins, the metals will attach to the metal center by using metal acetate, which are including copper acetate, silver acetate, and potassium uram chlorate to provide the metal iron to the center of the porphyrins. The applications of porphyrins are including photodynamic therapy, catalysts, dye-synthesized solar cell, molar sensor, and medicinal. However, when we're talking about the cancer is a major problem in many areas around the world. The cancer is uncontrolled cell that can grow or spread out by some of the cancer may eventually spread into other cells. Cancer starts when genes change and make one cell or few cells begin to grow multiple too much that can form a tumor. In cancer area, so around the world, they have a major problem in the breast cancer and prostate cancer. However, in Thailand, in 10 years ago, the number of the cancer deaths are increased gradually. The chemotherapy is an aggressive form of the chemical drug. The treatment or destroy the rapid growth cell in the body is usually used to treat cancer. As the cancer grows or divided faster than other cells, the most well-known chemotherapy is cisplatin or cisdiamine dichloroplatinum 2. And this compound was first found in 1845. The success of cisplatin they can use in many areas of anti-cancer. However, the advantage of the chemotherapy is shrink cell, or it can shrink the cell and make it easy to surgery later on, or it can reduce the chance of the cancers to coming back. The disadvantage of the chemotherapy, they also make the patient feel fatigue, diarrhea, loss appetite, loss your hair, and also blood clot as well. The introductions about the anti-cancer activity, as we focus on the porphyrins and also the first report on the anti-cancer for the porphyrin derivative is gold. So the gold porphyrin or gold TPP as shown in the A1, gold TOMPP is shown in the number 1C, and they used in various of the cancer cell line compared with the cisplatin and zinc TPP. The results show that the TPP, gold TPP and gold TOMPP has a high effective compared with the other cisplatin and other complex. Even though when we focus on the gold TPP and replace one of the para position by using OH to make them easy to dissolve in water. So it also show good IC50 compared with the cisplatin. The further study also explained about the benefit of the derivative of gold porphyrins to to give a low IC50 to treat the cancer cell line. However, the objective of this research is to synthesize characterized free base porphyrin with different methyl substituted group including phenyl, methoxyphenyl, and so on, to synthesize and characterize metalloporphyrins by adding copper iron, silver iron, which is silver iron 2, and gold iron 3 into the center of the porphyrins and their derivative, to synthesize and compare the chemical, physical, and the free base porphyrin and metalloporphyrin and their derivative, to study anti-cancer of the gold porphyrin complexes. The first synthesis of the aldehyde starts with the 4-hydroxybenzaldehyde and variety of the alkyl bromide. After that, we get the peel of the aldehyde. So within the aldehyde, they react with the pyrrole in the presence of propionic acid and reflux it for 2 hours. We get the free base porphyrins with a variety of the para-position substituent. The para-position substituent free base porphyrins react with the metal salt, which are including copper acetate and silver 2 acetate, and then is reflected with the presence of the DMF and dichloromethane for 5 hours. So metalloporphyrins was obtained as the purple color with different shade, with different long chain porphyrins derivative. However, the gold, we use the potassium uram chlorate with the presence of acetic acid refluxing for 5 hours. We will replace the proton in center by using gold 3+. All of the gold 3+ will located inside the center of the porphyrin rings, and it was purified by chromatography. All of the synthesized complexes and also free base porphyrins was analyzed by using various techniques. And here is show the 3 of the free base porphyrin, free base aldehyde that we use in the preparing the free base porphyrins. So the mass spectroscopy is confirmed, and also the NMR spectroscopy also indicate the expected aldehyde. So after we get all of the aldehydes that we expect, and then we try to make them to form the free base porphyrins. Within the free base porphyrins, we synthesize TPP, TOMPP, that O-methoxy on the para positions, or TOBPP that contain 4 of the carbon on the para positions of the ring. Or octyl, so that means we have 8 carbon located next to oxygen that bond with the para positions of the rings, and also decu, the carbon 10 numbers. We get success to prepare all of the free base porphyrins with a good yield, even though 9% is higher than some of the report, and the CHNs confirm in agreement what we expect. The mass spectroscopy show the mass spectrums of the TOMPP as the representative. The mass spectrums shown 735, as we expected one of the proton will attach into the complex when they run into the mass spectrometer. However, we found some of the small peak which indicate the fragment of the compound. The NMR spectroscopy also confirmed the expected compound. However, the NMR spectroscopy showed the phenyl proton in the range that we expect, and also is confirmed the structure by use carbon NMR as well. So that means all of the carbon NMR confirmed as we expect the free base porphyrin. After we get the free base porphyrin, we prepare the metalloporphyrins by adding the metal into the center hole by using copper 2+, silver 2+, and gold 3+. The results show very good yield for the copper. So however, we get more than 90% for copper TPP. Compared with the silver is the medium rate, medium percent yield. So range from 50 to 70%. In the gold of the TPP, the percentage yield is quite low, in range of 10 to 20% yield. However, all of the complexes are in agreement with the expected confirmed by mass spectrometry, and the CHN and elemental analysis. So the mass spectrums of the copper TOMPP show the major peak of 735, which represent the free base ligand. However, the copper TOMPP with the mass 797 is shown with a small u. The majority of them was lost the copper ion and formed the free base porphyrin in the majority in copper complexes. Compared with silver, the metal quite bond with the center stronger than copper, and we found the mass of 841 as the major peak of the silver complexes. In case of gold, only one peak of the 929 that represent the gold has a very strong bond with the metal center. When we look into the IR spectroscopy, especially on the spectrums of the NH stretching in porphyrin and also NH bending in porphyrin structure, the structure here shows the free base porphyrin. All those two peaks are found on the spectrums. So somehow when we make the complex with copper, silver, and also gold, the NH stretching and also NH bending is lost. So it's in agreement with the expected that the metal bond with the free base ligand by using nitrogen location. The UV visible spectroscopy show one singlet band by the electron transfer from S0 to S2, and also they have 4 of the Q band that's related with the transition from S0 to S1 with vibrational mode. In case of metalloporphyrin, the Q band was reduced to be 1 band. That indicate that the metal allow the vibrational mode turn into 1 transitions from S0 to S1. The free base porphyrins and also metalloporphyrin with various complex here show the redshift for the S band, and also the Q bands reduced from 4 to be 1. Within the calculations of the DFT and also the comparison between TPP, copper TPP and gold TPP, they show the S band is reduced from 417 to 415 and also 406. Within the Q band is reduced as well. The fluorescence spectroscopy indicate that the TPP copper and silver TPP, they show the absorption wavelength with a range of 529, with the emission wavelength found out at 649. However, the copper and silver is show emission spectra at 605. The absorption and emission spectra, the overlap area, we just make the overlap area here to calculate the band gap energy. For the band gap energy for the free base porphyrins, they are in agreement with the previous report, range from 1.09 to 1.92. And for the copper, silver, and gold porphyrins are shown in the table here. The gold porphyrins show very small band gap compared with the others. The ESR spectroscopy of silver 2 found out was observed. That indicate that the silver that we focus is the silver 2 plus paramagnetics for the square planar geometry. The G values for the silver TPP, TOM, and the rest of them show range from 2.05 to 2.03. In case of gold, the gold porphyrins show only 1 peak. That represents the gold 3 plus is paramagnetics. We get the silent signal in NMR, and the G value, they are in the range of 2.00, similar to the free electrons. The cyclic voltammetry for the free base porphyrins shown in the table from first oxidation potential range from 0.84 to 0.79. The greater of the carbon in the free base ligand is resulting the greater or the lower oxidation first oxidation potential. However, when we replace one of the center with the silver. So the silver allowed them to get the first oxidation potential very low compared with the previous free base porphyrin, the 0.8. At the moment is go for 0.4 and 0.5. The gold that do the same evidence. However, the gold show the first oxidation potential range from the 0.36 to 0.7. So that means the greater of the electron may allow them to have the lower in oxidation potential. Within the first oxidation potential and the first reduction potential, we take the difference between those two numbers and predict the delta of the E. So that's related with the energy band gap as well. However, for the thermogravimetric analysis, we can use this information for further applications in dye solar cell. So to prepare the dye solar cell, we need to heat the dye. So however, the stability of the copper TPP is quite stable up to 450. In case of silver and gold, the stability is lower. So especially for gold, they have the stability just only for 250. And later on, the dealkylations will found out, and also the porphyrins will decompose with the temperature over 400. For the silver, the stability is rise up to 400, and later on is decomposed to silver oxide. So the number of carbon is allowed the degree of the temperature decompositions will be greater. The thermogravimetric analysis is shown in here. And the DFT calculation represent the HOMO and LUMO from the electron density between the center and also the HOMO that found out electron density located especially on the phenyl rings. Within the DFT calculations for free base porphyrin, we found out the energy band gap is vary from 2.71 down to 2.65, as we have a large number of carbon is reduced into the smaller gap. So that means we get 2.65 for TODPP. And when we replace we replace the center by adding copper, silver, and gold, so the energy band gap are vary. Especially for gold, the energy band gap turned into 1.62. That may be because of the gold that we use is gold 3+. So energy band gap for copper is range from 2.47 to 2.57. For silver is 2.49 to 2.59. Within the gold is 1.61 down to 1.65. We did try about the biological activity within the S. aureus and E. coli bacteria. We found out that the clear zone of TOMPP is greater than TPP and TOOPP, TOBPP and TODPP. The copper showed the same trend, and also the silver as well. The MIC and MBC are reported here. For the S. aureus, for the MIC is about 320, and the E. coli is ranged from 160 down to 80, especially for silver TODPP. And the MBC minimum bactericidal concentration is ranged from 640 down to 320, especially for silver TODPP. And the MBC for the silver TODPP is low as 80 as well. So that's confirmed that both copper derivative and also silver derivative is active for antibacterials. For anti-cancer activity from the previous report, we found out that the gold TPP, they have a high effective on the cancer cell line compared with the cisplatin that's quite high, IC50. Even though when we replace one of the para position with hydroxy or try to replace some cisplatin derivative onto the porphyrins, it also show very low show anti-cancer activity as well. So for the taste of anti-cancer activity, in our experiment, we did try with the SKBR3, MCF7, and LLCMK2 for the normal cell. So biological activity results show here. For the IC50 for the TPP and copper TPP is quite high for the SKBR3 and also MCF7, even though it's greater than 80 micromolar, and for the copper TOBPP they show 141. We can see that the number is greater than the cisplatin. The replace for the cisplatin is quite difficult for these two cases. The copper is not active for the anti-cancer for this application. But thing that we found out is comparing between the TPP and copper TPP, we can see the reductions of the SKBR3 IC50. The result of MCF7. The result of MCF7 when we try on the gold TPP, gold TOMPP, gold TOBPP, gold TOOPP with the blue color and the light blue for the gold TODPP. So the results show here that all of the cell availability for the concentration is going to be reduced when we increase the concentration, especially for the gold TOMPP. However, the results are not in the way that we expect for the gold TOBPP, gold TOOPP, and TODPP. So this microscope information show the gold TPP show the majority of cells die with the IC50 4.30 micromolar, and also TOMPP with the concentrations of 25.35 micromolar. Within the IC50, we can summarize into the table. For the SKBR3, copper TOBPP is show about 25.22, and for the MCF7 is active for the gold TPP 4.33, and also TOMPP as we get the new information. Okay, so that one is the information that we can apply all of the porphyrins that we prepare for the antibacterials and also for the anti-cancer, especially for the copper TOBPP. For the SKBR3 IC50 go for 25.22 micromolar, and gold TOMPP that show very low within 25.35, that's close to the cisplatin based on our experiment. In conclusion, the aldehyde and also the free base porphyrin with the metalloporphyrins are success to prepare, and the absorption spectroscopy by using UV visible spectroscopy show one of the solid band with 4 Q band for free base porphyrin. Within the metal porphyrins, they show only one S band and also one Q band. And the excitation wavelength with 530, they give out the emission spectra in the range of 654, and energy band gap will calculate for 1.4 or 1.90. The ESR spectroscopy confirm silver that we prepare is silver 2 plus, as is show the signal in the ESR spectroscopy. The gold porphyrins also show the G value about 2.00. The free base porphyrins and their copper and gold porphyrins exhibit 2 reversible and 1 electron oxidation and 1 electron quasi-reversible reduction. So within the cyclic voltammetry is confirmed the electron density in the complex that increase the carbon, they will lower the first oxidation potential. For the MIC and MBC is quite active for the silver TODPP, especially for the MICs go for E. coli is 80. And the MBC value of copper porphyrins compared with compound were found at 640 for S. aureus and E. coli, whereas the silver show lower number at 640 and 160 for S. aureus and E. coli respectively. For the copper, porphyrins show cytotoxicity against both cancer cell of the SKBR3, and copper TOBPP showed the lowest IC50 at 25.22 micromolar for MCF7, and all copper 2 porphyrins exhibit IC50 value more than 100 micromolar. So the gold porphyrins complex AUTPP and AUTOMPP exhibit cytotoxicity on the MCF7 cell with the IC50 lower than 4.30 micromolar and 25.35 micromolar respectively. And the metalloporphyrins complexes exhibit non-cytotoxic on LLC MK2 cell, although the gold TPP show non-cytotoxic at the concentration lower than 5 micromolar. So finally, I would like to thank and the acknowledgement go to the friends from various countries. Dr. Mati Kandia from BMS University from Sri Lanka, Professor Shinya Ikeno from Kyushu Institute of Technology, Japan, Professor Yoshito Endo from Q-Tech, Japan, Professor Yuki Shirosaki from Q-Tech, Japan, Professor Toshimari Meda from Q-Tech, Japan, and also Professor Premjit Amat Maeklong from Thammasat University, and my PhD student, Dr. Thosapon Promsatit from Thammasat University, with the collaboration with Dr. Elvin Lim from Q-Tech, Japan. The research work here was supported by Science and Achievement Scholarship of Thailand and Japan Student Overseas Organization, JASO, and also acknowledgement to our team in our group from our chemistry lab here. And finally, thank you for your kind attention. Thank you.